In this video, we're going to introduce the different types of intersections between a straight line and a circle, right? So in the previous videos, we said, I just showed you the procedure when you're given a circle and you're given a line, basically, and you're asked to say, what is the point, to find the point of intersection between the line and the circle. Now you're going to get different kinds of intersections. It could intersect twice, it could intersect once, or it could intersect no times at all, right? So we want to talk about what that means, how to solve that, using our equations. And then this is just going to be the introduction. We will look at each of those different types of intersections in the next videos with more complex examples. But for now, we're just going to talk about the procedure, right? And hopefully understand what we're doing, right? So now, when you're talking about point of intersection, right? In our previous videos, we emphasize that when we're talking about intersection, we have to solve for those two functions simultaneously. So in this case, you have two functions. Since you have the function for the circle, which follows the equation x minus x1 squared plus y minus y1 squared, that's equal to r squared. That's your first function. Your second function is the straight line, which follows the equation y is equal to mx plus c. Now, in order for you to solve for a point of intersection, you have to solve these simultaneously. All right, solve simultaneously. Hopefully this spelling isn't wrong. Right, so you solve them simultaneously. How do we solve simultaneously? Usually the easiest way for us to solve that simultaneously is to take one of these expressions, the easiest one. In this case, maybe we'll take this y expression, we'll substitute it into that y expression, and then we just have an expression with x's only, right? So let's say using substitution. Okay, cool, right? So once you do that, now you have one expression. But the thing is, more specifically, we actually end up with a quadratic expression, right? So this is going to give us a quadratic expression. And the quadratic expression follows the format ax squared plus bx plus c is equal to 0. If you've substituted your x, maybe in that case it becomes ay squared plus by plus c. But essentially, the logic is exactly the same. You end up with a quadratic equation that's either in terms of x or in terms of y. So let's just go forward, assuming that we have substituted a y into this expression, which means the only thing you're left with is x's. So your equation becomes a quadratic expression in terms of x. And then we also know that in order for us to then solve for this, because that's the whole point, right? We're trying to solve for one equation. In order for us to solve for one equation, we can't have an x and a y in the same equation. So we substitute just to be left with the x's only. And then now we can solve for those x's. And then in order for us to solve for those x's, we use the quadratic formula. So we can say ax is equal to negative b plus or minus the square root of it's a mistake, b squared minus 4ac, and then all over 2 multiplied by a. Because this can either be plus or negative based on this sign over here, you're going to get two answers. You're going to get one answer for when it's positive. You're going to get another answer for when that sign is negative. So this is going to give you two answers ideally, right? However, sometimes it actually doesn't give you two answers. And this is where we have the different types of solutions, because if this gives you two answers, it means you have, all right, so what we're going to do is, let's actually just draw these out, right? So now, in this case, we're going to erase this and say, okay, we have three different scenarios. The first scenario is when this gives you two answers. If it gives you two answers, that means your circle look like this maybe, and then your line maybe look like this. If it gives you two answers, it means it has two separate points of intersection, right? It intersects at this first x value and then at that other x value as well, right? So that's your first scenario. Your second scenario is when it only gives you one answer. We'll talk about how it can give you one answer in a bit. But if it gives you one answer, it means the line and the circle only touch at a single point. So if you had this circle over here, and then you had this line over there, right? This only has to just touch just like that. Okay, let's just leave it like that. So essentially this means you have, your line is tangent to the circle, right? And then we also have another situation where, and also this point is the point where you x, there's only one x value because there's only one point that the line touches the circle. Hopefully that makes sense. All right, and our third scenario is when you have zero answer, right? You have zero answer, which means that your circle, there's no point at which your circle and your line touch, which means in this case, if this is your circle, maybe your line looks something like this. They don't touch whatsoever. So these are the three different scenarios that we're going to need to work with, right? So this is what they look like graphically. And this is when you have 2 points of intersection. We're going to call that point of int. And then this is when your line is tangent to the circle. And then this is the case where you have 0 points of intersection. Now, how can you get each of these scenarios? How come we have cases? In what cases do we get 0? In what case do we have 1? And in what cases do we have 2? All of that stuff depends on this equation that we wrote over here. So let's just rewrite that formula. Our quadratic formula, which is the formula that gives us these x points, says x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Right, so the result of this actually depends on what we call the determinant. So the determinant is this little expression that's inside there. That's what we call the determinant. Right? So now the thing is, if your determinant is positive, let's just say, for example, your expression looks like this, right? So if you have x is equal to negative b plus minus the square root of 4, and then divided by, actually I wanted to put actual numbers over here. Let's just say it's, this is 1, and then this is divided by 2 times 1, which is just 2. So in this case, you're going to get 2 distinct answers, because once you put this into your calculator, you're going to get negative 1 plus square root of 4, which is 2. So negative 1 plus 2, which gives you 1. 1 over 2, it gives you a half. Your second expression is going to be negative 1 minus the square root of 4, which is 2. So it's negative 1 minus 2, which is negative 3 over 2. It gives you negative 3 over 2, right? So if whatever's in this bracket is a positive value, it's going to give you 2 distinct answers, right? So basically, if your determinant is positive, it gives you 2 answers, which means you have 2 points of intersection. So in this case over here, your determinant is positive, right? That's your first scenario. Your second scenario is, let's just say, for example, again, we'll use the exact same numbers. What if I had the expression, I simplified it to the point where I have negative 1 plus minus the square root of, but inside this bracket where my determinant is, my determinant came to 0, right? And then you divide it by 2. So in this case, now we have, let's just try to calculate these very quickly. Negative 1 plus, the square root of 0 is always going to be 0. So it's negative 1 plus 0, which gives you negative 1, divided by 2, that gives you negative a half. Perfect, that's the first answer. But what if this sign were negative? It's going to be negative 1 minus, the square root of 0 again is 0. So it's negative 1 minus 0, that gives you negative 1. Divided by 2, again you give that negative a half. So the thing is, when this determinant over there is 0, your answer repeats itself and you only end up with one answer, right? So you only end up with one solution, which means over here, in order for us to get a tangent, which is a tangent means it only touches at one point. It means we've only got one solution, and that's because your determinant is 0, right? So hopefully that kind of makes sense. Your determinant in this case is equal to 0. All right. And then your third solution. The third solution is, okay, again, I'm going to use exactly the same numbers as before. If we had negative 1 plus minus the square root of, if we made this negative 4, right? If you threw this into your calculator, negative 1 plus minus the square root of negative 4 is not a real number, right? So now we're going into complex numbers, which you don't have to worry about for your AS, thank goodness, right? But if you do this into your calculator, it would give you an error, which means x is equal to an error, which means there is no solution. So the moment we have a negative inside our square root, that means we have no solution. So the moment your determinant is negative, it means you can't have an x value. There's no answer here, which means there is no point of intersection. So that means our third situation is when your determinant is negative. Okay, so essentially, it's all about the determinant. I might use this symbol to denote determinant, but we need to focus on our determinant. Now, it's going to be a little bit tricky because there's a lot of different steps, all right? The first step is going to be, okay, substitute to get your quadratic, right? Your quadratic is going to be a result of these two formulas coming together. Once you have that quadratic, now we need to say, okay, what's the determinant of that resultant quadratic? Is it positive, which means those two functions, those two graphs that came together to make the quadratic have 2 points of intersection? Is the determinant equal to 0, which means the line is tangent to the circle? Or is the determinant of the resulting equation negative, which means there is no solution, which means the two don't meet at all, right? So those are the steps that we just need to make sure we follow. Bring those together, and then we start to look at the determinant. So that's what we're going to be doing in the next couple of videos, all right? We're going to look at all those individually. We're going to start off with the two solutions, the tangent and the negative, and then we'll look at a couple of examples after that, all right? So hopefully by the time we're done with that, it makes a little bit more sense by the end of it, all right? So hopefully for now, this introduction made sense, and I'll see you in the next video.